Welcome. Today we're going to take a quick jaunt down memory lane and port the game Maelstrom from SDL2 to SDL3. So why Maelstrom? Well, Maelstrom is the game that got me into game development. Back in the days when Doom was 320 by 200, Maelstrom was the full-color asteroids game that ran at 640 by 480. And I reached out to the author, Andrew Welch at Ambrosia Software, and asked him if I could port it to Unix, and he graciously agreed. And that was the beginning of my game career. I initially ported it to X11 running on Unix, and then later ported it to SDL1 when that came out, and then SDL2 when that came out, and now, 20, 30 years later, I'm gonna port it to SDL3. So I haven't looked at the code in a very long time, many years, and so this will be interesting. I'm going to show you everything that happens from scratch here. So first, we're going to look and find the game on the internet. What is this thing that we are going to port? Here we go. This is the main page. We're going to go ahead and download this so we can see what we're doing. Here, I'm going to put it into my desktop file folder. Let's see, where is that? Here we go. Come on. There we go. And that is totally not what I wanted. All right, well, that's fine. We'll just create a new folder and dump all that stuff in there. So you'll see here we've got all of our dependencies and assets and the game itself. So let's run this. And I'll turn down the volume a little bit. There we go. All right, so it works. Okay, so before we go into actual code porting, let's do the easy thing and use SDL2 compat to run this thing on SDL3. So first we'll look up SDL2 compat. We'll grab the latest release. And this is a 32-bit application, so we're going to download the x86 binaries here. And all we need are these two DLLs. So let's go back to the Maelstrom directory and rename this sucker, just so we have a backup of the original file that it came with. And drop in SDL2.dll and SDL3.dll. So this version of SDL2 actually loads SDL3 dynamically and forwards all the SDL2 calls to SDL3. So let's see if it still runs. So far, so good. Yep, looks good. Okay, so now that we know the compatibility layer works. Let's dive into the source code. So I have WSL installed for Windows. That's Linux running on Windows. And this includes command line tools for Git, compilers, but we're going to use Visual Studio for our compiler. So let's go ahead and go to our C drive ports directory. We don't have anything in here yet. And so we'll need several pieces. First, we're going to need SDL3. We're going to need the Maelstrom source code, and we're going to need SDLnet. So let's grab those. Maelstrom source code is right here. And I actually happen to have this on GitHub. So let's go grab it from there. And once we finish grabbing that, let's also grab SDL. And SDLnet. Okay, so I haven't looked at this in a really long time. Let's see. So we've got a bunch of source code. We're looking for the Visual Studio project. Okay, so I see it under visualc.zip. And there we have some library headers, some libs, and our projects. So let's open that up. Ports, Maelstrom, you'll see Maelstrom.sln. And we're going to open this up in Visual Studio. And we're going to migrate it to the latest tool chain. Okay, so let's just build this and see if that works. So far, so good. That went into the debug folder. We have maelstrom.exe. Let's throw that back into our Maelstrom game. We'll back up the original one. And see if this still works. Yep. Okay, so now we get to the fun bit. We verified that the game works. We verified that we can compile it using our tool chain. And now let's go ahead and replace the SDL2 stuff with SDL3. So first we'll build SDL3. And let's see, we built this as a 32-bit application. We'll go ahead and do the same for SDL. Wow, that was fast. All right. And let's go into, just replace our external headers and libraries directly. So we'll grab all of this stuff and we'll just delete it. And then lib, we'll just delete all of this too. And we'll go over to the one that we just built. Nope, not in here. That actually got output up here at the top level Win32 directory. So we'll grab this and drop it in. Now we also need SDLNet. So let's see if we can build SDLNet here. There's a Visual C directory. That's promising. Let's grab another copy of Visual Studio. Open that up. And build that. Okay, so it can't open SDL3.lib. Now we need to go and tell it where that library file is. So I'm just going to make a quick change here to the linker general. Let's see, where is that? Additional library directories. Let's add it here. I'm going to browse for SDL, Visual C, Win32, debug. This is the folder that we want. Okay. Now, we were building the x64. We actually want 32-bit, so let's do that again. Hey, that looks good. So let's open up that folder, grab that DLL and library. Throw that back in our Maelstrom library folder here. And we'll grab the headers too. So let's go back to SDL, go to the include directory, and we'll just grab the SDL3 directory here and plop that in. All right, so you'll notice that we have an SDL3 directory where we had the raw headers before. That's because SDL3 changes the include path. So SDL3, the name SDL3 is always in the header path. So now let's go back to our Maelstrom project. Let's go ahead and close SDLNet and SDL because we're going to hope that those work perfectly. And we'll just focus on Maelstrom and build. So yeah, it has no idea where SDL is. So we're going to fix that. So we've got a whole bunch of include directories here, or include directives here, that just say include SDL.h. So we're going to go ahead and replace all of these in the whole project with include SDL3 SDL.h. Replace all. All right. So before we go any farther, and before I start to do things like commit to Git, let's go ahead and create a branch for this work. So let's go back to Maelstrom. What branch are we on? We're on the main branch. So I'm going to create a branch, SDL3. And then I'm going to check that out. So anything that we do we're going to make changes and commit to SDL3. So that wasn't very many locations. I'm wondering what's happening here. Is that really all the places that we included? We also have some includes of SDL-types.h. So I think we're just going to replace those also with the main header. So we'll do this again. Only 5 occurrences. All right, so now we're going to try to build. And of course, we'll get lots of errors because we're still calling SDL2 functions. So now we need to know, how do we convert things from SDL2 to SDL3? Here's another header. We're just going to change this. Okay. And those functions look correct, maybe? Maybe not, that's okay. So you see here we've got a bunch of things like undeclared identifier. We have swap16b16 renamed to swap16be. So before we go any farther, let's just go and look at the migration document and see what we need to do. So we go to STL. Go to the source code on GitHub. And then we're going to go to the documentation and look at intro readme migration. Here we go. And if you were following along and you wanted a different way to get there, you could go to the wiki, libstl.org, and go to, let's see, installation, source code, migration guide. Here we go. And so this is a very comprehensive document that talks about all of the changes that went from SDL2 to SDL3. So the first thing that we're going to look at is some function conventions. We can skip that for now. There's a rename symbols that will actually go through and convert SDL2 functions to SDL3. So let's try that. Or we could use a semantic patch. Let's just try renaming the symbols though and see what happens. So first we'll do a git diff just to see where we're at. And I'm going to go ahead and commit this as a first commit. And of course, since this is a fresh installation, I don't typically use nano, but this will work. Okay, and I'll just change my editor to Vim. Make sure Vim is actually what I'm using. Yep. Okay. So we've saved our progress. And let's go ahead and run that script. Let's see. Rename headers.py -- all symbols source code path. So this is going to be in the SDL build scripts directory. And our source code path is the current directory here because we're in the Maelstrom directory. Ooh, we need to git. I don't know if we want that. We'll see what happens there. Okay, so if we look at the changes, it's gone through and changed a bunch of the old symbols to the new symbols, which is great. It's not going to change things that actually change functionality, but for simple renames, this is a good start. Okay. That's probably not what we want. That's okay, we'll come back. So let's go ahead and see where our build errors are now. Oh, well, it actually went through and changed our headers. That's not what we wanted. So let's go ahead and back all of this out. And instead, let's be more specific about what we want to change. So we're going to do that. We're going to grab all of the source files and everything in maclib, screenlib, and netlogic. That'll be all of the source code. That looks better. And here we go. More of the things that we expected. So let's try that. And we still have redefinitions in the SDL directories. So the reason why we have that is because we previously changed all the headers in the external directory. Visual C external. But we didn't tell Git that we had changed those. So let's go back to that. And let's just delete that directory again. Let's start fresh there. Copy that over. Put it back in. And this time, let's go into the directory and tell Git what we did here. Okay, so we added some new files, and oh, well, these weren't in Git before, but they are now. That's fine. So let's just commit here. Added SDL3 headers and libraries for Windows. Okay. And now let's try our build again. Okay. So here we have a bunch of SDL headers. This one got renamed because SDL lowercase mutex got turned into SDL uppercase mutex, and the rename script isn't smart enough to know the difference between an include and something else. So, but right above here, we already included the main SDL header, which includes all of these. We can just remove these. Let's see. Output. Let's look in our output for more include. Cannot open include file SDL Indian. That's okay. We're going to change that to the main SDL header. Anything else? Another one. That's the same one. It's the header. Anything else? Okay, so now it's complaining about our actual usage of these functions. Now, we started out. Okay, let's just double check this one more time. And look for cannot open include file. here, STL3, STLnet.h. We haven't copied that over yet, so let's go ahead and do that. So this is STL, STLnet, include STL, oh, it's STL3.net. Okay, so let's go back to our include directory, and drop that in, and we'll change this header to STL3.net. Okay. See if we have any more of these. Looks like we have a few. Because previously we would include a header for just for each piece of functionality that we needed. Here we're just including a single header. And if I were going back through and doing this again, what I would probably do is create a single header that everything would include and just include that in it. Like either using a precompiled header or just a single global header. But that's fine. And feel free to skip forward if you want to skip all of the header renamings. This is STL3.net. Okay, I think that's everything. Yep. Okay. So now it gets a little more fun. So we've got some things here like read.io, change function signatures. And while we've done the simple renaming, there are some things that change function signatures that we can use our other script to do smarter renaming. So this is a semantic patch. And coccinelle is a program that allows you to do more complex naming, change code transformations, and we use this in STL to ease the migration. So what we'll do is go back to our WSL shell, and then we're going to use spatch. That's not installed yet, so let's go ahead and install that. Apt install coccinelle. I think that works. Let's find out. Nope. Patch. Nope. Into coccinelle package. It is called coccinelle. Maybe I mistyped it. And maybe I have to do apt update. There we go. That's going to install a bunch of dependencies. So in the meantime, let's go back to our document and see how we use this thing. So all we have is file itself. Let's see if that says there. Yeah, here we go. spatch s-sp file, and then the code that we're going to change. So let's do that. So that is also in the build scripts directory. Spatch --sp file stl build scripts stl migration. Make sure we're doing this right. And then we're going to just give it the current directory. And that is going to go into patch. Looks like it only touched one file. Let's give it the same set of paths that we gave the rename function. So this is star.h, star.cpp, maclib, screenlib, netlogic. We got nothing. That did not work. Ignoring all but the last specified directory. All right, well, let's do it one at a time. Okay, and then we'll do the directories. Logic.patch. maclib.patch. screenlib.patch. Okay, so we've already gone through and done the renaming using another script, which this would also do. So I don't expect a whole lot of changes here. So let's see what we got. Screenlib.patch is empty, netlogic.patch is empty, maclib.patch is empty. So the only thing that actually has changes is in the patch itself. So yeah, those changes look good. So I'm going to remove all the .patch files and take a closer look at our patch here. So yeah, in the key event handling, key sim was removed. That looks correct. Create RGB surface function change parameters. That looks correct. If the joystick button state change from a constant to a Boolean, that looks correct. So yeah, I'm just going to go ahead and apply this. This is a little silly. We have event key state equals true. We can clean that up in a minute. So let's go ahead and apply this patch. And to take a look at our diff here. So we've got our renaming and some more header changes, and that all looks good so far. So let's go and change this equals true, which is silly to just remove equals true. Those are two places that we'd expect it. There and there. And let's see where we're at. So we still have lots of errors. So let's start hitting them up. Controls.cpp seems like a fine place to start. Keyboard event has no member named state. Okay, so we've got the key. So there's a couple of different approaches here. We can go look at the definition of this and see what is there. Let's look at that definition. Keyboard event. And yes, there is no state. It changed to down. Let's go ahead and change that. The other thing we can do is go to the migration guide and see what it says there. So this is key events. And hey, there you go. SDL pressed and release have been removed. For the most part, you can replace uses of these with true and false respectively. Events which had a field state to represent these values had those fields changed to bool down. And that's exactly what we saw here. So that one's fixed. Let's see what else we got. Key code is undefined. Why is that? I think this just changed from key to key code. Let's see if this is listed in the migration header as well, or the migration document. Key code. Key code is now UID32. Okay. Let's just change that. Here's our handy state, change it down. Key sim is undefined. Let's look for key sim and see what happened there. Following structures have been removed. What do we do instead? That's a good question. Let's see where this is getting called. So this is only getting called from one place. Box key press. So that's a function handler. So where does the key callback get called? So it gets called in handle key press. Handle key press gets called with key sim. And of course that doesn't exist anymore. So let's just change this to, let's see what these handlers actually do with this. Because I don't know that we actually need the full key sim. The key sim used to be the key and modifiers together. Yeah, so it would be the scan code, sim, modifiers, and let's see if we're actually using the modifiers anywhere. So it's looking at the sim, sim. Okay, so let's look for the other key handlers. Apparently that was the only place that was called. That's kind of silly. All right, well, since we were only looking at the sim, or sorry, we were only looking at the key code, let's change it to key code. Handle key press, we'll just take the key code. Looks like that was virtual, so let's go ahead and change that here. Key callback to key. Key callback will need to change. I'll go to the other handle key press functions. Just change this to key. Isn't using anything else, right? fun. Oh, we should not have done that. We really should be using text input here, but that's okay for now. This is key. Okay. And then here, this is just key. Okay. So that was our first error. Create RGB surface. So this one wasn't able to be converted, but if we looked at our patch, this converted to format index. STL pixel format index. And then this is just create service. Does that look right? No, that does not look right. Let's see what our patch did. Index 8, that's what we want. Okay. Let's see, button, why is that red? Button applied to pixel format. I don't think that's correct. Let's see. Yeah, that's the surface. Okay. Oh, well, this format no longer exists. We actually have to query the palette from the surface. We'll get to that. Let's see some more keysims. Let's look for this everywhere in our source code. Key code. And again, feel free to skip past this. I'm doing this in real time and haven't looked at this code in many years, so this might take a little while. STL key code. Key code. Okay. Full screen desktop. Let's see here. What happened to that? We'll go back to the README, look for that. This has been removed. You can call get window full screen mode to see whether or not an exclusive full screen mode will be used. In this case, we're just toggling full screen is actually toggling full screen desktop. And since that's the default, we'll just change it to full screen. And then set window full screen now takes just a bool. So this will be false and true. In fact, let's look for all of these places. Is that all of them? Okay. Let's build again, look at our errors. Return value does not match the function type. What happened here? STL pixel format. So STL pixel format is now just an enumeration, and this has been renamed pixel format details. Let's just confirm that in the documentation. Yeah, pixel format has been renamed pixel format details and just describes the pixel format, does not include a palette. Pixel format enum has been renamed pixel format. Okay, so this was returning the pixel format details. Out of curiosity, let's find out where this was being called. So find all references. Was this not even being called? Let's just remove this and see if that's safe to do. Just do one more search for that, just in case. Yeah, that wasn't even being used. Let's just remove it. Okay, so what's our next error here? And if, no, too many arguments in function call. Let's see, show cursor. Why is it saying that? It's been split into 3 functions: show cursor, hide cursor, and cursor visible. So which ones are we doing here? This is show cursor. This is hide cursor. Okay. Let's see what we got here. This is not related. This error list is dynamically updated. That's cool. Right. So start text input takes a window now. So where is our window in this header? We don't have a window. Awesome. So now we need to pass through a window. Maybe. Let's see what's the best way of doing this. You know what? We're not going to pass through a window. We know that we only have one window. So let's do STL windows equals STL get windows. That takes a count, which can be null. So if windows let's use the first one. So why is it complaining about that? So it says here, this is a single allocation that should be freed with STL free when it is no longer needed. Okay, so if we got a value, we'll free it. And we'll just do the same thing over here in stop text input. And our error here is value of type STL window star cannot be used to initialize an entity of type STL window. So what did I do wrong here? It looks like star. Maybe the compiler is not aware of what's going on here. So let's just try building this again and see what errors we actually get. Well, because I forgot a star. Okay. There we go. Okay, moving on. So we actually need to get the palette out. So let's do that. Equals still get surface palette. That's what we want from our button. If palette, which should always be true, but just in case. And then we're going to remove those. Boom. I'm guessing we have to do this somewhere else as well. Here for our label. But once we set these, The first time we set them, let's see, if we've used the surface, the palette before, then we'll need to let SDL know that the palette has actually been changed. So let's just do this. Set surface palette label palette. And so internally inside of SDL, it's going to create mappings from one surface to another when it does a blit. If it's never done that before, then changing the color here will do the right thing. But if it's already built that mapping, then set surface palette will just be a hint to let it know that that these colors have changed and it needs to redo that. Alternatively, what we could have done is had a separate array of colors and called set palette colors, which would have done the same thing. But this works. Let's go back to the other place where we were. And call that here as well. So we're going to do that on our button. Okay. And it looks like we have one more place to do this. So here's our radio button. And we're going to set the colors here. That's not correct. Radio label is what we want. Okay. And put pixel 3. So this is high bit depth support for writing to the screen, but I think we might just simplify it here. Let's see where put pixel 3 is being used. I'm gonna have to fix this as well. Where are we getting the screen format from? We're actually creating an ARGB 888 texture here. And our screen foreground is going to be an 8-bit texture. And screen is where is screen coming from? Clearly we have some work to do here. It's a member variable. So let's see where we assign that. Equals. Equals, okay, focus foreground. So this is going to be either foreground or background. And we already know that screen foreground is going to be 8-bit. I believe screen background is going to be the same. Screen background equals, yeah. So screen foreground is an 8-bit surface, and then we focus on the foreground, and then screen background is going to be the same. So this is kind of, when we're looking at the screen format, this is always going to be 8-bit. So I'm just going to simplify this and say put pixel is put pixel 1. And I'm not going to bother fixing these. I'm just going to remove these. I'm just going to assert screen STL pixel format bytes. Let's see, STL bytes per pixel that equals 1. So I'm just going to insert that. We're looking at bytes per pixel here, so it's the correct macro to use. It's kind of silly to have a function pointer that's, always exactly one function, but we can clean that up later if we want. So let me go back to the header. These other functions no longer exist. Yeah, the best part of updating code is removing it. Things you don't have to migrate, it's even better than migrating. Let's see here. Go back to our error list. So fix that. Okay, so now we're on to ScreenLib. So this is the code that puts things on the screen, and it's going to change quite a bit. So create window changed, and now it takes a title, width and height, and flags. So we don't need to have this centered, that's the default. Actually, it's not the default, but if we want to center it, we can do that later. Video flags. Let's see what flags we pass in. Video flags. Do initializations. These probably come from command line parameters. Let's see here. Do initializations. It's called somewhere else. The video flags. Let's get set to full screen desktop. We already know that that's just changed to full screen. And that takes care of windowed. And we're just going to remove the full screen flag. And that's it. Okay, so that takes care of that. We know that the video flags are good. And our create window call is what we want. Create renderer changed. Now it just takes the window and the name. So let's just look at our handy migration guide to see what changed there. Second argument is no longer an integer index, but a const char star representing a renderer's name. If you're just using a for loop, you can pass the string directly. Passing null is the same as passing -1 here in SDL2. So hey, you were passing -1, so let's change that to null. And then let's look what happened with this flag. Replaced with prop renderer create present vsync number during renderer creation, and STL prop renderer vsync number after renderer creation. That's fine. It looks like we're always setting it. There's another trick we can do. After we create the renderer, we can just call STL set render vsync renderer 1. That way we don't have to worry about properties. Create texture. It looks like this hasn't changed. Create RGB surface. So again, let's just change to create surface. We've done this a couple of times now. Flags went away, and then it's width, height, and format. And we know that our 8-bit format is STL pixel format indexed index 8. Okay. And we're doing the same thing here. And I'm just going to be explicit about this. Okay, so we have a staging surface here. So this is the same format as our texture. Why do we have a staging surface? Let's see where we use that. So we lock the texture into the staging pixels. We do our work. And then we unlock the texture. Okay, that's fine. So this is create RGB surface with format from, I think, got much simpler. I've been combined into a new function, create surface from, and the parameter order has changed for consistency with create surface. Okay, so create surface from, and then that changed to width, height, format, and then pixels and pitch. So width, height, format, pixels is going to be null because we don't have any pixels yet, and pitch is also going to be 0 because we don't have a pitch yet. So we'll get those when we lock our texture later, as we just saw. Okay, go back to our errors. Set render logical presentation. All right, so what happened with that? So this got renamed, but the parameters also changed. So let's see what the parameters are. So it's render, width, height, and presentation mode. So the default presentation mode was letterbox. So let's use that. And we have some nice autocomplete here. Boom. Okay. And then here, map RGB takes details and a palette, but what we actually want here is map RGB surface. Let's confirm that in the migration document. Take an optional palette parameter for index palette lookups. Get RGBA. Now looks map RGBA surface format. Now should be changed to map surface. There we go. So this was map RGB. It's going to be map surface RGB. And we can remove the format. And then we can do that a few different places here. Screen foreground. Now this is going to just do a map surface RGB, and the staging texture is going to map into an RGBA 32-bit value. And interesting. And then mapping into screen foreground, we already know that that's an 8-bit surface, so that's going to map into the palette that we have. So that's all good. Map surface RGB, foreground. Looks like we're doing that a few different places. Screen BPP is now STL bytes per pixel on the format. We already know this is going to be 1, but that's fine. Here, bytes per pixel again. And there's lots of opportunities for optimization now that we know that we have a fixed size, fixed format. Pitch is going to be still important. Put pixel can be a direct memory access if we want. But again, we're doing a simple port here, so we won't go back. We won't optimize right now. So this is bytes per pixel. You know what? I'm going to go back and just copy this because it looks like we're doing it in a bunch of places. So here, everywhere where we were doing this, I'm going to change that to that 4 times. Okay, what do we got here? Map RGB, we already know that's map RGB surface. Is it still red? Map RGB surface. Map surface RGB, there you go. Okay. Create RGB surface undefined. We already know our screen format is 8-bit. But create surface width, height, and screen format. Okay, so here we're trying to set the palette of the new surface to the same as the palette of the screen. There is a simpler way to do this in SDL3. So what we want to do here is SDL set surface palette. It takes the surface, so area, and then the palette. So here we're going to just do get surface palette from the screen. So this actually does palette sharing. If we go through and change the palette that's used by area, that will actually affect the screen. So we want to make sure that we're not doing that anywhere. But this is in screenshot stuff. So we're just making a direct copy of the screen. That's fine. Screen mem, we're doing a mem copy. Interesting, okay. So show cursor also got split into 3 functions. Let's take a look at that while we're sitting here. Show cursor, hide cursor, and cursor visible. So the first one is whether or not the cursor is visible. Then we hide the cursor. Why are we doing this? Because long ago, we used to be writing directly to video memory, and we needed to hide the cursor so that it would remove the cursor from video memory. But we're not doing that anymore. So this is unnecessary. Okay. Again, create surface. Width and height. Screen foreground format. I love removing code. And then again, we're going to set the palette. Boom. And then artwork format bytes per pixel. And then here, set surface color key, the RLE Excel flag no longer exists. Let's look up the details on that as well. Not documented. What? Okay. Let's look for our RLE. RLE acceleration. Okay, so set surface color key takes a bool to enable and disable color key. RLE acceleration isn't controlled by the parameter. You should use set surface RLE to change that separately. Okay, so we're going to do that. This is going to be 2 calls. So we're going to set the color key and set surface RLE artwork true. And this is true or false, and then the color key. So this should be true as well. So RLE makes a big difference. RLE is run length encoding, so it'll actually take the all the transparent areas and turn them into a single operation of just skipping rather than copying pixels. So this, for this game, that's a pretty good win. So we'll leave that enabled. Again, TL bytes per pixel. Okay. Let's see what errors we have here. So this is the last one in this file, it looks like. No, maybe not. Faded equals not faded. Faded is an int. Faded is used as a bool. Seems silly. Okay. Because I'm anal, I'm going to go ahead and fix this. It's a bool. And where should we set that? False here. Okay, what else do we got? Buff equals not buff. Interesting. So we know that this is a black and white bitmap here. So changing the value is correct, but this is also fine. Is that fine? It's actually not fine. This is ones and zeros. We'll leave that and let the compiler complain about that. That's fine. Special key is taken care of. Pixel, it's complaining about old code. So let's go back to real errors. Why is that complaining? Software surface. Again, oh, this is interesting. This is creating a bitmap surface. So create surface. And this is 1 bit. So is that LSB or MSB? Create surface. Here's some masks, but that doesn't cover what we want. And it's not documented here. So let's go look at the coccinelle script because I think that we did some work there. STL, build scripts, index 8. So yeah, so creating a surface with 1 bit depth is index 1 LSB. Cool. Window. Okay, so this is still complaining about old stuff. So let's go ahead and build again and see what our updated error list is. Okay, so this is setting the palette. This is setting individual palette colors. So let's grab the palette. So we'll get surface palette from the image. And then STL set palette colors. So we're setting individual colors here. So we'll just set individual colors here as well. So this is background. And that'll be the first index and just 1 color. And then we'll do the same with the foreground. Index is 1. Boom. Okay. Cursor shown isn't used. Yep, we removed that. If open is unsafe, we'll ignore that for now. Callback is not a member of audio spec. Oh, audio. Let's come back to that. Maybe you don't come back to that. That's all audio. Okay, right, IO does not take arguments. Let's see what happened there. So it just takes a pointer and a size. So adding 1 is unnecessary for all of these. Okay. Cool. Key sim, we missed one. This is just event key.key. Actually, we've already assigned it to key there, so we'll just special key. Here's another palette thing. And we're setting the values there. And this gets pretty routine after you've done it for a little while. Like, I remember what I did for the last thing. Set palette, surface palette, buttons are surface. There we go. What's happening here? Float to int. Let's not worry about those. Bool. Oh yeah, that's an important warning. So this is saying that it's trying to use Boolean in less than or greater than operation. So the type of this change from int error code to bool success. So we're going to change less than 0 to not. Less than 0, not. If we don't do this, then returning true would not evaluate less than 0. Is that correct? Yes. Yeah, so this is what we want here. Num joysticks. Let's see what num joysticks is now. Replaced with get joysticks. So, and then open joystick takes, instead of an index, it takes an ID. Okay, so we just initialized the first joystick. So SDL joystick ID joysticks equals SDL get joysticks. And then we don't care about the count because we're just going to check that. If joysticks we do care about the count. If joysticks 0, and we can open it. And you might be wondering why we changed from indexes to IDs, and that's because indexes can change out from under you, but IDs are global and unique for the life of the program. So it's a safer way to deal with hardware devices. So here we're going to free this. And we know we have to free this because if we look at this, it says it's a zero terminated array of joystick instance IDs are null on failure. This should be freed with STL free when it is no longer needed. If you don't free it, you'll have a memory leak. So there we go. That's taken care of. Another palette issue, same deal. We're actually just setting a single value. Okay. Oh, I see. We're not setting a single value, we're setting it in a loop. So let's get the palette at the beginning of the loop. And then we'll set all of these. And then at the end, we'll just let STL know that the palette changed. Oops. What the heck? STL surface palette, surfaces icon, and palette. Okay, so this is saying this doesn't take one argument. Right, because this changed to return whether or not the read succeeded, which is pretty handy to know. So we were assigning the value. What we want to do is fill in the value. And then, of course, we don't want to overwrite it. So we'll remove this. Right. This formatting seems a little funky. Why is that tabbed out like that? Because this is spaces, and this is tabs. Okay, I'm not going to worry about that right now. Read IO. Again, we know that we don't need to have that one in there. Same here. Just takes the pointer and the size. This is an important warning as well. So get ticks changed from returning a uint32 to a uint34 so that we didn't have to worry about wrapping. However, this is fine. We'll just change this to 64-bit, and it'll just work the way we expect it here. Okay. Activate button takes a uint16. What is this? It's a float. Oh. So the mouse events now take floating point values to handle sub-pixel precision. We don't actually care about sub-pixel precision in this game, so we'll just cast it. And we'll cast it to int because we don't want... Do we want negative values to show up as negative values? What does that do? So these are uint16 values. So we're just checking against range. If it's out of range, we don't do anything. So if it's wrapping, it'll be very large, which will be definitely out of range. So that's fine. So we can just cast. So when you're dealing with this, make sure you know what you're doing with the values, because casting might not be the right thing for you. Okay, so that's fine. Another key sim. Key.key. Start text input. Do we have the window here? Seems like we ought to. What I'm going to do, I'm going to make this a function in screen. Start text input and screen stop text input somewhere here. Okay. So screen is a frame buff. And we have a window in hope, somewhere. Yep, there's our window. Void start text input. STL start text input window. Void stop text input. Let's just look for the places that we do this. So in dialog, do we have a screen or frame buff handy somewhere? We do. Look at that. So remember what we did here? We don't need to do that. We're just going to call screen start text input. Why is it complaining about that? Because this is static. Okay, well, we'll leave this alone then. Okay, screen start text input. Looks like that was the only place that was called, but still, we've encapsulated it. It's a little cleaner. It'll be a good change. Here, key events. Here we're properly handling text input. That's great. Although I suspect we are not. Oh yeah, we're handling UTF-8. That's great. Okay, so back to our errors. Where are we? Stop text input we fixed. What is that? UDP socket. Oh, networking. So Ryan went ahead and completely revamped the networking layer for STL3. In this video, I might go back and just build STL2 networking just out of convenience, because we don't need any of the features in STL3, but we'll come back to that and see. Networking. Yeah, I don't want to migrate all that code, so I'll just build it. So I will fix up scores, and then let's take care of networking. Again, this is now an output parameter. Notice that we're not actually checking the return value. Naughty developer. What happens if we don't check the return value? Let's see. We're initializing everything to 0, so if we don't happen to rate it, we'll just get an empty scoreboard, and that's fine. Then write IO down here also doesn't need that one. Okay. Syntax error. Okay, so net score is a lot of errors and net play. So let's go back. Rather than use STL3 networking and have to port all of that code, since it's not actually released yet, let's take a look at STL2. STLnet git checkout STL2. We've made some changes to the project, so let's just get rid of them. Okay, and we'll go back to our STLnet solution. Build that. Oh, we can't do that because that depends on STL2. All right. STL3 it is. There isn't a migration guide yet for that. So let's go back and do some of the easier porting. So here we have font serve, and this is checking bits per pixel. So we're going to use the macro bits per pixel on the format. And here we are getting, oh, interesting. So we're getting the colors, palette, STL, get surface, palette, text. Okay, so we are swapping. You know what? Naively, you might think you can do set palette colors palette colors 1 for the first one. Number of colors is 1. This will be the address of this. So what this would do is take the first color, or the color in the index 1, and put it in index 0. So let's actually look at the source code for this and see if that's a safe operation, because this is pointing at a value rather than copying the value directly. We'll probably have to go to the source code in here. Let's open the project. Set palette colors. What does it do? So it's going to do exactly what it says. It's going to take the color that's pointed to here and drop it in the palette at the index that you just specified. But here we are swapping colors. So we're going to overwrite the first entry with the second entry. And then when we go to set the second entry to the first entry, we'll have lost it already. So we actually need to use a temporary value here. Temp equals palette colors 0. So we're going to save off the 0th color. We're going to take the first color. Yeah, English doesn't work well for 0-based indexes. Anyway, we're going to take the color at index 1 and drop it into index 0. And then we're going to take the color that we saved off that was in index 0 and put it in index 1. Address of temp, index 1. And then we don't need to call set palette colors because we've just done that here. Okay, that was silly. We actually can just leave the code alone. So we're saving off the colors, we're swapping them in the process, and then we're going to set the color palette colors to what we've swapped. Much cleaner. Okay, cool. And now we are back to audio and networking. Then some uninitialized variable warnings. Let's see. Some here. It's per pixel, it's already fixed. All right. Here's more casting for our events. We already know that that's safe. That takes int this time, okay? And then UN64 to UN32. Text. Okay, So here we've defined ticks as a macro that calls STL get ticks, which again is now 64-bit. So the way we're using it here it's safe to cast this to 32-bit. And I might eat those words later, but if this hits 32-bit values and then goes past it into the 64-bit range, it's just going to wrap 32-bit lower bits. So let's just cast it to uint 32. We already know our code is safe for wrapping, so that should be safe. Okay, so now we really are done, except for audio and network.